Hello, welcome back to my bench. Today we have an older piece of equipment that decided to give up the ghost. This is a Bell-R AM RF amplifier. Basically, it's a fairly fancy AM radio. And whoops. Oh, smells terrible. Okay, on the back we've got RF in, RF level for the outputs. We have modulated RF out if you want to take it out to another piece of equipment, and a frequency RF out for checking frequency on a AM monitor, which is what we use here and here. So basically, it's not very much. The front, we have a meter right here that gives you a relative output of this thing. It's not based on anything, but you want to keep it inside of the green and at about the 5 or 6 mark, because this thing puts out a fair amount of AM. So anyway, it's hosed. It just stopped this morning, and of course the alarms all went off. Scared everybody to death because they thought we were off the air, but we're not. They really proud of this. They want to keep any kind of noise out of this thing, I'll tell you, because it has definitely got a lot of screws in it. Do I have anything? Yeah, I'll just throw them in here. I've worked on this before a while ago. I think, if I remember correctly, I believe at the time, a couple, 3, 4, 5 years ago, whenever it was, I think I bypassed the brute force power supply dropping resistor and put in a regulator, just a LM78 something, I don't remember what it was, and that might very well be the thing that died, because had to get it back on the air, didn't matter, and the resistor that dropped the 22 volts or whatever this thing runs went from a resistor to a floating carbon trace out in the middle of the air. It was pretty awful. Bad design to begin with in my mind, but back in the days when this thing was made, which I believe was in the 70s or early 70s, they didn't have all the fancy stuff that we've got now. They used things like dropping resistors and let them get hotter than the hinges of Hades, and didn't care. So what burn up? Aha! Yep. Looks like, okay, here's what I did the last time. Here we can see this. There's the voltage regulator I put in, and I can't see what it is right at the moment, but we'll find out. Let's see. It's a 7806, and it's connected into here, and if you look right there, that does not look healthy. I'm going to have to get the manual out and see what that is in this thing, but I have a feeling it's going to be associated with that poor thing back there. Let me get the manual out and be back. Okay, so I looked at the manual here. How am I going to do this? And that particular resistor is R1. As we can see right there. It would actually be faced around this way for us, but there's R1. And it is on the power supply board, of course, and it's right there. So it goes up. Oh, let's see, it's got a 1N753 diode coming off a 16 going to ground. So what all did I take out of here? I don't think I took anything out of here. I just replaced it with, well, we'll have to find out. First of all, gotta get that 620 out of there. Gotta tear this thing apart. It's all kind of wired in here. No, I took the screws out, but you know what I mean. Alright, be right back. You know, before we do any of that stuff, I'm going to check this 7806 and see if it's any good. Well, it's not shorted. It's not shorted, but that resistor sure as heck went to a bad spot. Alright. Okay. Board's out. Let's do some simple testing here and find out what's good and what's not. I'm on diode check. 586, 0.574, 562, 0.585. That's good. This one's a Zener. 0.64, 7 and 0.8. Well, that's going to ground, but I don't know. We'll see. What else we got here? We got 1.6 that way, 0.6 that way, 0.6, 1.1 and growing. Well, that's interesting. There appears to be a little Zener here. What is that? That is sort of not looking good. It's broken on one end here for some reason, and that is VR3. I'm not the first person to have worked on this thing, I'll tell you that. VR3 is a 965, 1N965B. And this is probably nothing to do with it. I may have just moved it accidentally or broke it off. It's been soldered to. Taken apart and soldered to, so I don't know. But it's right there. Voltage regulation for pin 4 of this IC. That's part of the oscillator. So it's voltage regulation for pin 8. Okay, so 1.39 one way, 0.69 the other, so it's fine, but I gotta get that thing soldered back on there. It's not working now. I think that's got it. Let's see. No, it doesn't. Alright, I need a little more light on the subject. Sorry, folks. I'm at the shop. I'm not at home. So, my ability to do this is not quite as good. Wow. Can't. It does not want to solder. Wonder why anybody broke it loose. It does not want to take solder at all. Well, I got it. I might have to come back and find a 965 to replace that with. Oh well, let's check the others. Okay. That's pretty much all the diodes. Let's check this transistor here, because the regulator's fine. This transistor that I've taken out right here is Q1, and Q1 is 2N4037. It's right there, and it's attached right directly to that resistor that took a huff. So if you got it is original. If I can find, yeesh. Okay. So, check this guy out. Let's see, that is that. Open, 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 open. Yeah, it appears that that transistor is just gone, and it may have shorted before it did its thing. So let's put it on the tester here and find out. Before it died, it decided it was going to take out a resistor. Nope. It's good. Okay. See? Good. Alright, so that's fine. So what do you do when all of your parts check out okay? You throw them across the room. Where did you go? Here you are. All your parts check out okay, but the device burn up a resistor. Well, there are a couple of ways you can handle it. First one is to start checking for current. Wow. There. Is to start checking current and find out what's wrong. Of course, it could be, too, that the... Come on. Boy, they made the holes exactly the right size for the for the leads. Okay, it could be too that the resistor just got hot and burned up, changed value, and slowly did itself in, and that is entirely possible. Not tremendously probable, but highly possible. And we will check that out. I mean, there's nothing we can do about the resistor. Resistor is shot. I mean, shot. Just gone. But it got hot a lot. And it's just powdering as I take it off here. Of course, so's the board. Okay. Resistor pieces. Wow. I don't know. Well, what we're going to do is we're going to get another resistor here. It's supposed to be 620 ohms. It looks like a 2-watt. Probably don't have a 620 at 2-watt. Does anybody? Let's see, 1, 2, 3, 4. No. There's no. Wow. I'm gonna find something. Be right back. Alright, so here's what I've done. Basically, I've put the board back in. I've got a resistor. I found a 670 ohm resistor. Close enough, I guess. And I put it in there. It's standing up, right there. Right there. And I've got my meter, and I'm going to check voltages on the 7806. Got 5.99, 6.01 volts coming out with a 36 volts going in. This is why the resistor was originally on this thing just croaked. And this resistor is pulling 4.8 mils. I find that hard to believe. It's stone cold. Stone cold, but I don't know if it's working. I have the noise you're probably hearing now is I'm using my HP 8640B to hold the camera tripod down so I can look down from the top. I've got it turned on, and now it's making noise. So I need a anything length of coax. I don't think this. I think this is 59. Yeah, I don't care. It's not going to be much of a difference. I want RF in. Get the meter leads out of the way so I don't short them out. Yeah, now we're not drawing any current. Alright, so I'm going to turn it up. I'm going to turn up the... wow. That is not working. So... by the way, this is 77. I was wrong in the early years. 920 into no modulation, output plus. No, I got nothing on our input frequency on this thing, so I'm going to have to figure out, is the RF on? Yeah. Yeah, well, okay. So, that didn't work, but I do have 7 volts now. Got to find out why that little guy right there decided to die on me. Interesting. Something was drawing a lot of current. Be right back. Okay, so we've got some parts. Here we go. I got a one in whatever it is, 753, which is a 6.2 volt Zener. It goes up here to the one what was busted, and appeared to be okay when we checked it, but it wasn't. And I've got a 15 volt Zener here, which I'm going to replace with this one down here that's somebody had cut loose and not soldered onto the end. I don't have a whole lot of faith that this is actually going to fix it, but we'll find out. We'll take this one out first here. Because, well, it's easy. It's just sitting there. And the that end came out easily. That end came out easily. Alright, so here's my 15. Like I said, I am not altogether sure that this is going to fix it, because when that minus 6 volt Zener went out, it allowed 27 volts, minus 27 volts on the rest of the circuit, which is not a good thing. But we'll find out. Somebody stole my solder. I'll be back. Okay, after a long search, I found my solder. Oh, it wasn't that long of a search. It was about 10 minutes. It had been stolen to go off and do other things with its bad self. Okay. Let's put this Zener in here. I might need a little more heat on the old iron for this one. Yeah, let's take that up to about 400. Okay. Because this thing's got a pretty good ground plane on it. You got to remember, in radio station stuff, this equipment was made so that you could have it co-located, which means on premises basically, and not have any interference from that huge tower pumping out 1,000 watts or more outside your window. So when they make this stuff, they make it pretty RF proof from the outside in. It's not so much anymore because nobody does that. I mean, pretty much the smaller markets, they might be co-located with their transmitter and their studios right on the same premises, but most of the time they have their studios in their city of license downtown someplace, so they can be seen and all that kind of stuff, and they don't really have to worry about it. But in the old days, that's the way it was. Of course, this is AM radio. This thing, it basically just a very fancy, very high gain AM radio is all this thing is. Because the modulation monitor, frequency monitor, and all that stuff that's hooked up to it needs a lot of input. Alright, so this one goes this way, and there we go. Now I'm putting, these things had half-watt Zeners in them. I'm putting 1 watts back because, well, A, I have them, and B, I don't know, the brute force method of voltage regulation that was has been used for eons. Makes things hot and burn up. And I just don't feel like doing this again. In another 30 years. Okay, well, there's the Zener's in. However, we're going to look at this. If we look at this thing, let's get you in here a little bit. All right, if we look at this thing, that Zener I just replaced, I need something to point with. I don't know. I'll get a greenie. All right. That Zener I just replaced was this one. This is a 6.2 volt, and it goes off out of number 16 here, which is, where's 16? There's 17. Here's 16. So it goes out number 16. Well, number 16, other side of the coin. Okay, number 16 here, if we follow it around, comes right here in through a 100 ohm resistor on the other board and goes right to this CA3029 for the negative voltage. Goes up through a 680 ohm resistor, a pot, and into this FET for the drain or source. And there's a 5 microfarad capacitor over here on the gate. I'm afeared that this 3029 might have taken the brunt of it, but we're going to find out. Put you aside for a second. I do not want to pull this thing out of here because this one's kind of a pain, but we'll take some measurements real quick. Like, here's our CA3029 right there. Let's, whoops. There. Come on. You can do this. All right. And we're looking at pin 6. So what I want to do first is just see if pin 6 is shorted. 1, 2, 3, 4, 5, 6. Pin 6 is not shorted. That's good. But I did get a short somewhere. Okay, that's a diode. No shorts on that thing to ground anyway. So that's a good sign. What else we got? Oh, we got these guys here, but they're not. Yeah. See, that's the only thing that this negative voltage actually goes to here is that. So, shall we take the chance? Oh, what the heck. No guts, no glory, I guess. Let's put it back in. Put it back together and see what blows up. I still have this resistor disconnected over here, so I can put the meter in series with it and watch the current. But if this fixes it, I will be kind of well, I'll be happy, but also I'll be quite surprised. Alright, so this one says B, probably for blue. This one says, I have no idea what it says. However, I took pictures. Alright, so there's my picture. Why does a phone do this every once in a while? It just decides, you took it sideways, but I'm not going to show it sideways. Yeah, okay, the white one goes here. The yellow one goes down here where it says Y. Oh, that's amazing. I think I did this when I had it open the very first time to put this thing over here in it. Red goes here. This is why you take pictures, boys and girls. Nobody's smart enough to remember all of this stuff. I don't care how long you've been doing it. You either write it down or take a picture, and nowadays, just take the picture. Alright, so we got this one here, that one there from the transformer, and the center tap from the transformer goes over there. Oh, for crying out loud. Okay. That's right, that's right. Let's see, this little cable here, whoops, goes, this one goes right here. Whoops, nope, wrong. Ground. Yeah, silly. And then this one goes here. I have noticed over the years that my manual dexterity is not what it used to was. Okay, there's a black one from the meter. Goes to ground here. This one up here goes here. Isn't this riveting? Okay. That goes there. And this one goes up here to this little coil that they got standing off the board. That's probably some sort of yeah, that's a tuned circuit, I'm sure. And white. Well, pink. Pink goes here. And then there's another purplish, violet, I guess. Yeah, I'd say it's violet, alright. And it goes there. What goes down? Okay. First of all, you come off of here and you go down here. I'm missing one. Black wire goes there. And the wire from the light, which appears to be trapped underneath here, goes over here. I think the light's dead. I do believe. So I'm not just chasing after myself here. I'm going to check this light. Light should be open. And the light is... Wow. See what I was talking about? Manual dexterity? Okay. CM385. I wonder if I got any of those. I don't think so. If I do, I'm going to have to search. So we'll just say no for a minute. Put it back in. It doesn't do anything, but it'll keep it there. Alright. Power cord. Voltage down. Power on. Cross your fingers. Let's find out what happens. Well, nothing's going to happen until I put this thing milliamps and get a couple of jumper leads. Green and red. Won't fool the electrons too badly. I'm going to have to put some goop on that, I think. Alright, so millivolts. Alright, we're coming up. Milliamps, stupid. Okay. Alright. We're still drawing about 7 milliamps. Interesting. Well, let's see if we've got any kind of signal out of this thing at all. Okay, I had to drop down in video resolution here on this. Sorry about that, but my 64 gig video card filled up in 10 minutes on high resolution. That's not even the highest. And this is just standard, but we'll have to live with it for now. I guess I got to get more video, more card. But anyhow, I've got input going up here. I've got 920 going into it. About plus 20 dB. I got nothing on the meter. So, okay, what we got here is a failure to communicate, folks. All right, 7.2 milliamps. Let's do some voltage measurements. Find out what we got. I am supposed to have, well, I don't know what I'm supposed to have, but let's check that, what I got here. Got no voltage there. Okay, why? I got six volts there, and I got 2 volts there. Okay, well, something's not right. Something is drawing that down. That's kind of what I was afraid of, and wonder what it is. Well, let's see. What is that 3K 2-watt resistor? So 100 ohm resistor back here. So my minus, let's just make sure I've got it here. Minus, let's see, 1, 2, 3, 4, 5, 6. I got 1.5 volts on that one, and pin 13, 548 on that one. Alright, so we've got something drawing this down. Well, okay, well, we're back, and I had to make a couple little changes here. The resistor, and this is me showing. This isn't even, as Dave would say, a trap for young players. This is just being stupid. See that resistor right there? Do you see that that's blue, green, and red? Well, I didn't look at it real careful when I put it in. That's supposed to be blue, green, and brown. 7.2K resistor in place of a, 6.2K resistor in place of a 620 ohm resistor. Ay, ay, ay. Check your work. You'd think after all these years I would know better, but hey, we all do stupid stuff. So now, I changed that. I've got my diodes in. I checked everything else. I've got it all set up. And now we go for voltages and see what we got. For voltages, let's get the let's get this camera over here and see if I can get this set up on top of something so I can see. I've somewhere along the line I appear to have lost my my other, no, quit that camera. I appear to have lost my other tripod. I don't know where it's at. Anyway, so let's turn it on now. Let's see. Okay, so the video is going to be a little bit different, huh? Alright, there we go. Turn her on, and let's see what we got. Our input voltages are 35 volts positive and 35 volts negative. Our B plus 6 volts is whoops, don't short it out, David. 5.83, and our B plus negative is 6.5. Cool. That's good. And now let's see what happens when I turn on some RF. Please work. Please work. Oh, all right. We got RF. There we go. Turn it down. Turn it up. Okay, so I'm feeding it with about a minus 50 through out of the generator. Minus 50 dB at yeah, 920. Head on, and it works. It's amplifying. Finally. Alright, so let's go through this and see what we did. Besides, make stupid mistakes. Alright, so basically we had a fried resistor, just cooked beyond belief. Actually, it broke in half when I took it out. Looking for pointers, what I'm looking for. Right here. Got a fried resistor. Bring her down a little bit. Right here, and that was 620 ohms. I put in two 300 ohms, and it came out to about 610. That's close enough. Actually, at 270, but they're out of tolerance a little bit. They're not great resistors to begin with, but I put two 1 watts in. That makes, you know, about 2 watts. They're not actually drawing that much anyway. It's what happens is that the resistors over a very long period of time, even if you're not pushing them, they will change value, and that changing value just gets worse and worse and worse, and eventually you end up with enough to just go off. I mean, just bad. And then they'll poof, burn up. We changed this Zener diode, which is a 1N753A, which is a 6.2 volt Zener. You notice that the negative end is going, or the banded end is going to ground. That makes it a regulating a negative voltage, which comes off of one side of the transformer here. The other side of the transformer goes through, and I've replaced the Zener a long time ago. I replaced the B plus 6 volt Zener with a 7806. I would have done that here, but I don't have a 7906, and it worked for 30 years on a Zener, so it's probably okay. We also found a busted Zener over here. That is the 15 volt supply that goes up to where is it? 15 volt supply, which is right here, which supplies everything else through this oscillator. So, well, you know, yeah, this IC, which is a dual flip-flop, comes off the ringer down here. So this it supplies this, and it was broken. So it means that the output of whatever this transistor here was not being regulated to the right voltage. Surprised it didn't take that out, but it must be a pretty hefty, hardy little guy. I checked this 3030B here, which is a 27 volt Zener, and it is correct, and that 3053 does supply the right voltage. 27 volts, has 27 volt Zener. This VR6 is where I replaced it with the 7806. The caps have been replaced in recent memory, somewhere along the line. So everything actually is working out just fine. This old stuff is not what you would call really critical about exact voltages, but they do work. So anyway, that one, that Zener there was open. This guy was burnt to crisp, and that Zener was busted. Basically, that was the repair, and if I hadn't put a 7.2K in there instead of, well, it's actually, the thing is, it's supposed to be 6.7K or 6.5K, but it's not. It's actually 7.2K, which is even worse. So that resistor is no good anyway, in the trash it goes. But I replaced it with those guys, and everything's fine. So there we go. It works. We'll put it back on the rack, hook it back up, and call it a day. But anyway, good lesson. Check your work. Look carefully. See what you've done. Did you do it right the first time? Alright. Hey, thanks for watching. Hope you liked it. And if you did, give it a thumbs up. And don't forget to subscribe down there. Subscribers are good. And talk about it too. Leave some messages. I like to read messages. Anyway, thanks for watching.